So, so far, we just had a brief introduction on databases, specifically relational databases. So by now, I would expect you to know why we need a database, what is a database, and what is a relational database, what does it mean? So, what is a relational database? What do we mean by that? Anyone? Yeah.
Like two different tables that share like a column or attribute, so you can relate them.
Yeah, the tables in our database are related to each other, right? Or they are linked. Not all the tables, but some tables through a common field or common attribute, which is often, not always, the primary key of one table that appears as a foreign key in the other table. And we talked about what entities, what are the attributes, and so on. But I'm also going to do a quick review because I realized the recording didn't have audio last session, and hopefully this is working today. And so, what is an entity? Wake up, class. Is, for example, let's say we want to build an ER model. We want to design a database for an airline. Okay, so what could be the possible entities there? Passengers. What else?
Staff, like the pilots and people will be working on the plane.
The type of plane.
Plane information.
Airports.
Airport maybe, yeah. So we can say, let me say like, we have to think about when we want to design a database, we have to think about what we want to keep track of, what data in that application, website, in that system, what data we want to keep track of. And that will help us understanding what could be the main entities, which later will be our tables, right? So whatever entity we define as a design model will become our tables. And whatever attributes these entities have, they become the columns of our tables. So for instance, as your friend said, we can have like, if you want to like design a database for an airline, you want to like keep track of passengers information, right? Or users information. You want to keep track of the flights, right? And we may also want to know the information about the airplanes, the flight dates, time, etc., the airport. So whatever you want to keep track of, you want to keep that data into your database and help you define what your main entity is. So what is an entity? It could be anything, like a person, right? Could be an object, could be a place, right? Could be, for example, a restaurant. Your entity could be a restaurant. And then what could be the attributes? Restaurant location, for example, right? Restaurant star or level, I don't know, cuisine, and so on. And so this is about an entity, and then attributes we said that provide further characteristics about the entity, like for example, if, as I said, if restaurant is an entity, some attributes could be, for example, the location of the restaurant, cuisine, etc. What if an entity is the classroom? What are the features of the classroom? Students. So if I have a classroom, because this is a classroom, which is your entity, right? And we show entities with rectangle, right? And this will become a table in your database, right? So you will have a table of classroom. So if there is an attribute like student, let's see the first. What do you want to write here? And in the student, the characteristic of a classroom can I have like a student as an attribute here? It's actually good to do like this way, because then you can realize what are the problems and it's okay, you can like design whatever you think, and then you realize it doesn't work. Student itself is an entity, right? The student has some characteristic itself. Students, you want to like keep track of the student's name, right? Student email, student number, and so on. And so this couldn't be an attribute of the classroom. How about
Capacity.
classroom capacity, right? So you want to know, for example, if you want to assign a classroom to the course, and let's say this is a large course, like for example 10 to 15, which is a large course with many students enrolled in that course. So you cannot have any classroom with that capacity, right? So this is a good feature. What else?
Location.
Location of the classroom, or like the
I think maybe the like a course associated with it, depending maybe if it's like if it's one like the classroom supports one type of course, or if it's more based on the teacher, maybe assign a teacher to that classroom. Just a kind of way to connect the classroom outside.
Yeah, it's what you describe is correct, but does it justify classroom as an attribute? Does it justify as the attribute of the classroom?
I would think there has to be some sort of link between a classroom and the course. I'm not sure exactly what it is.
Yeah.
But
So there is a link between classroom and some other thing, of course, right? But those other things are other entities, right? Because links are between entities, not the attributes, right? Attributes is just providing further information or characteristics of entities. So for the classroom, we can have like classroom location, maybe. We can have classroom equipment or capacity, and so on. And design, depending on how complex or simplified assumptions you have, that you want to like keep your model simple or complex, and what details you want to include in your model. Classroom could even be like an attribute, and I will explain how. Okay. So, but for now, for example, if you think about a course as an attribute of the classroom, or a student as an attribute of the classroom, which is not correct, which is wrong, I will explain why. So one way to identify whether that thing could be a good attribute is first, does it provide like a characteristic? Is it a characteristic of the classroom? Neither course nor the student are not characteristics of the classroom, right? And on the other hand, both the student and the course have their own attributes, right? So we have, for example, what could be the possible attributes for the course? And you can think about if you have a course table later in your database, what do you want to store in that? Course code, exactly. So we have, for example, a course entity, right? Course entity. And one attribute could be the course code. Another, what are the other attributes? Yes?
Maybe faculty belongs to.
I like how you consider all the entities as the attributes. So I'm not doing a good job here, I think. So when you say faculty, student, course, all these as attributes of, for example, class, or for example, considering faculty as the attribute of the course, we are talking about an entity with its characteristics. So everything is related to that. For example, yes, students and supervisors and faculty are related to each other. But am I a characteristic of an instructor? No. Is a course my characteristic? No. It doesn't provide any information about me. What are my characteristics as a person? My name, if I have a student number, if I'm an employee number, right? Or email, or address, something like that. Faculty itself, again, will be another entity, right? Faculty, professors, instructors, you name it, right? And then this would have, for example, course code as the attribute. Let's say course here. And course name, right? Can course name be an attribute for the course? And another way to think about it again, as I said, these will be the tables and the attributes will be the columns of your tables. Okay, so if, for example, you have a classroom table, you have a classroom entity which become a table, right? And you define a student as the attribute, it doesn't work. What do you want to write here? A student name, student ID, a student email, or what, right? And it's a classroom table. So in each table, in relational databases, each table should represent an entity. And we want that table structured in a way that each row is unique, right? And also we don't want to store multiple values in one cell for the reason I explained in the last session, right? Because, for example, if you want to access or query that table later, you don't want to like do string matching there. You want to go specifically to that cell and access a specific value, not multiple values, right? Let's say you want to get a, for example, course code, right? And or course ID, you want to find a course ID. And then if you have a specific course ID, if you store multiple course IDs, let's say in student table, that doesn't work. So here, we know that this is not a good attribute here. Why? Because for each table, we want to have each row be unique, right? So for example, let's say if you have a course table, right? You will have a course ID, course name, maybe like a brief description about that course, and maybe more attributes, right? And this could be, for example, 3421. The name is database, and then we have, for example, 3401, which is AI course, and then we have 4412, which is the data mining course, and so on. Now, what is important here is that first, we cannot store multiple values in one cell. What is a cell? This is one cell. This is one cell, okay? So we don't want to store multiple values here, which means if I give you a course ID 3421, right? This is unique. This uniquely can identify a course. If I tell you 3401, you know it refers to the AI course. If I tell you 1015, you know this is a, like introduction to computer science course, and so on. So each row should be unique, and that's why each table should have a primary key. The primary key is a unique identifier for your table. Okay. So what could be the primary key in the course table? We said primary key is unique identifier. So when you think about primary key, when you want to choose primary key for your table, there are several things to consider. The most important and basic one is that it should uniquely identify each row, right? Now, sometimes you may come up with different things. Like, for example, if you want to consider, for example, for course code is maybe course ID, right? And some of you may argue that course name could also, like, if course name is unique, we can consider course name as primary. Why course code is a better primary key? the course name.
Maybe like 2 courses can have like the same name.
Not only that, but even if we are 100% sure that all courses have like the same name, course names can get very long, right? And they are strings, whereas we are dealing with mostly like integers, short numbers, and they are faster for accessing your tables. And for the primary key, when we learn later about the indexes, you'll know that primary keys are often like, not often, always, they are indexed for faster querying your tables. So, in a table like course, maybe the best option for the primary key is course code, because course code can uniquely identify true, right? If I give you a course code, you should be able to tell me what that course is. And let's say student table. If we have a student table, what are the options? A student number, can it be a primary key? Yes. Yes, a student number can uniquely, always ask this, can it uniquely identify each row in that table? If you have a student table, so let's say you have a student table here, right? And then you have a student ID, a student name, right? Let's say first name, last name, phone, and maybe address and so on, email, and I'm going to also talk about this. So we said a student ID or a student number. It could be every primary. Now the focus here is not the primary keys. I want to mainly focus on concepts like entities. How first of all, how you come up with the entities for your model. Second, what are the attributes? So we want to practice a lot to understand what are the entities and what are the attributes and how to differentiate that from each other, right? So for example, let's say instructor address. Is it an entity or attribute? Everyone. Attribute, right? It provides a characteristic about instructor, right? So we have several practices with that, and let's move into the relationship. So relationship is the link or association between entities. For instance, is there any relationship? Could be any relationship between a student and course. Yeah, we discussed it last week. We said each student can enroll in multiple courses, right? And each course can also have many students enrolled in that course. And we even described that, so if this is a student, right? If this is the student and this is the course, and here, let's say we have a student ID, first name, last name, just to have some attributes here. And we said, okay, they have a relationship, and that relationship is, what is the type of relationship? Is it one-to-one, one-to-many, or many-to-many?
Many-to-many.
Many-to-many. Just to review, if you've missed the previous class, when you want to identify the type of relationship, we can either have a one-to-one relationship, or one-to-many, or many-to-many. Now, how to identify that? So, for instance, for the students and course, you have to see how many instances of one entity are related to how many instances of other entity. So, for instance, each one student can enroll in 0, 1, or more courses, right? So for sure, this is not one. Now, it's either one-to-many or many-to-many. It depends. So when we say a student can enroll in many courses, a student enroll in many courses, and you show it with this sign. And I see a lot of times, I saw in previous classes, students confuse it a lot, put this sign here. especially for many to many, even if you get confused, it doesn't matter. For one to one, it's okay, but for one to many, it matters, right? So when you say a student enrolled in many courses, the many comes here, okay? And for each course, we can have how many students enrolled in each course? Is it like only one student? No, like database, we have hundreds of enrollments, right? So this is a many to many. And we also said that whenever we have many to many relationship, because the relational databases cannot handle that, and we'll explain it why. Because in relational databases, we want our tables have like atomic values, which means we don't want them to like storing multiple values in one cell or repeating the rows, right? We want each table uniquely, like each row be unique. And so here, what do?
Break it down to one to many and many to one.
Breaking it down into two one-to-many relationships. I saw one of you emailed me asking about this specifically, that how is it a one-to-many relationship? So we call this associative entity or composite entity. And why did we do that? Just quickly reviewing that. So we said whenever two tables or entities are linked in your ER model, so when there is a relationship between two entities, what does it mean? It means that later in your database, these two tables are connected. That is, the student table should be connected to the course table. Why? Because if I ask you a student name, I want you to be able to retrieve the courses the student enrolled in that, right? Enrolled in, sorry. Or if I give you a course name like 3401, I want you to let me know what are the students or who are the students enrolled in that course, right? So these are all stored in the database. So we can see the enrollment for each courses, which students enrolled in each course. We can also see which courses each student enrolled in. So there should be a link. Is there any question up to here? Is it clear that there is a link and these will become our tables? Okay, so now how do we link them? How do we show that link in the tables? So if I keep it this way, if the course table only have course information, like course ID, course name, description, only these three. And then in the student, I have a student ID name, etc. Let's say I have student ID 1 is Mona, 2 is Nathan, 3 is Alex, 4 is Sarah, and so on, right? Now, and I'm asking you which courses Mona is enrolled in. Can you let me know? Yeah.
You would use the primary keys from both the course and student and combine them into one table?
Yeah, we should have, like most of the time it's the primary. Sometimes tables are connected to more than one column. And we have that example in our slides. But for now, let's keep it simple. Yeah, so we need either, like in the student table, we need something about the course, like the course ID, right? That links these two tables together. Or in the course table, we need a student ID, right? So that giving each course ID, I know which students are enrolled in that course. And then we had a discussion where we have to add that, right? So should I add the student ID here? Or should I add the course ID here? I don't know. Let's see. So what if you add, so this is your primary. What if you add the student ID here? Is that possible?
No.
Why?
Because there'll be multiple.
Yeah, multiple entries, right? Because for the database course, we have 100 students here, right? Can we store it this way? No, what's the problem? It's not atomic, right? It stores multiple values in a cell, right? And later when you want to like search for a specific, for example, a student ID, then you like don't you don't have that specific. Yeah, you later when you learn, for example, how to query your database, you may later understand this. But for now, we can just think about it this way, that we cannot store multiple values because later it's not impossible, but it's difficult and less efficient to access your data like that. So that is why we don't store data like this. So this is not the way. And here, again, for the same reason, for each student, one can enroll in multiple courses, right? I may enroll in 3421 and 4412 and so on, right? And so we cannot store course ID here. So you can see why relational databases cannot handle many-to-many relationships, right? Now, because we cannot handle many-to-many, what is your suggestion? Associative entity, which becomes a third table here, right? This will become your third table. This will be an enrollment table. And we show it with this sign, which is a diamond inside a rectangle. Why? Because this was actually a relationship. This was a many-to-many relationship. And then we converted it into an entity. So it's both an entity and relationship. So it's an entity which shows me, it should be shown by a rectangle and also relationship, right? It was a many-to-many relationship. So this is the enrollment, which I showed there. Now this becomes your third table. Now here we can have course ID, student ID, and maybe more attributes, like for example grade, right? So now in this table, always for your associative entities or composite entities, you always add the primary keys of the both entities it's connected to. Which are those here? What are the like the minimum two attributes for any associative entities?
Student ID and course ID.
Student ID and course ID. And why? Because we said when we link two tables together, right? The primary key in one is added as a foreign key in the other. So when you link a student to enrollment, a student ID is added here, right? Because a student ID was primary key there, so it will be added as a foreign key here. And similarly, course is connected to the enrollment, so course ID will be added to the enrollment as well. And most of the time, oftentimes, the primary key of your associative entity is a combination of like these two primary keys. That is, your primary key doesn't include only one column. So for example here, what is the primary key? Course ID. Primary key, student ID. Here, the primary key will be course ID and student ID together. Does it mean that we have two primary keys? Do we have two primary keys here? No. Primary key is always one, but it consists of two columns. So this will be your primary key. Why? Because course ID and student ID together can uniquely identify each course. Of course, if our assumption is that each student can enroll in each course only once, right? So for instance, if you say this is 3421 and this is, I don't know, Alex, right? I just write the name because it's easier. You can think of it as a student number, okay? Now, can I have like, can this row be repeated? No, it cannot. Because Alex cannot enroll in database multiple times based on our assumption. If you assume that no student can enroll in a course multiple times, maybe once in fall, another time in winter, yes, then your model gets more complex, then you have to add also the semester here, and then the combination of the semester, student ID, and course ID together for your primary keys. Okay? Now, the important thing about primary key is that whatever your primary key is, should uniquely identify each row in your table, which means all the rows in our tables, in relational tables, should be unique. I can repeat 3, 4, 2, 1 here as much as I want, right? Is it okay? Yes, because this will refer to different students, like this could be Mona, this could be Sarah, and so on. So same course, but with different students. Similarly, I can have same students, right? I can repeat the student because the courses will be different, right? This will be, for example, this will be another course, and so on. Now, if you check, each row is unique, right? And that is why this combination is your primary, because these two columns together can uniquely identify each row, okay? Course ID alone in the enrollment table cannot be primary because it is not unique, right? The student number also the same, is not unique. And so these are the two, like the minimum attributes that each associative entity can have. Like, is it clear? The many-to-many relationship, where we add when should we add the composite entity, what does it do? Yes?
So composite entities only occur in the manipulation.
So I know like when you actually enroll in classes, they also have like enrollment ID or something to track what it is. If you added something that was unique to this table, like an enrollment ID, would it still be composite or would it turn into an entity with just two?
No, it will be in that case if you add another. Sometimes we later learn about surrogate keys. Okay, so it's another form of like primary key. It's auto generated by the system. You have also that option. For example, if your model get more complex, let's say you also have semesters here, and or maybe in this case you have to define your primary key based on 3 columns. Maybe sometimes you come up with like 4 columns as the primary key or 5 columns. In those cases, it's better to add surrogate key or like identifying another column. So if in a system enrollments also have a unique ID, then that's okay. So that will be your primary key. So as long as you have a column that can uniquely identify your table, that is your primary key. Unless you have like several options. So for example, let's say in the student table or any kind of person table, employee, anything. You have their name, the student name, you have a student number, you have email, and let's assume emails are unique, right? Student numbers are also unique. You may even like argue that my database is very small and there are maybe like this, there will be no like 2 students with the same name, etc. So I want to like, since my data, my current data, in my current data, no 2 names are the same, I want to like keep a student name as the primary. Can I do that? Is it okay if let's say I check the data and I have, let's say, a list of 100 students, no 2 students have the same name, so they are all different. Can I consider student name as a primary key? So if you want to answer my question, think about this. Primary keys can uniquely identify each row. So this is 1, right? This is the minimum required. And we said that the names are unique here. So can we keep it as the primary key?
We can also have the same issue of like name that's really long or something like primary key and then happen to have no names matching.
Not ideal, but we have a bigger issue here.
The nature of the name attribute can guarantee that every name is created.
Yeah, we can guarantee that. Maybe exactly. Yes. So maybe right now in my data, no 2 names are the same. But can you guarantee that they're like tomorrow? Maybe there is a new student. which has a name similar to another student, right? So the name can be repeated. This is one topic. Now let's see what are the other issues, like the email.
Emails, even assuming there couldn't be any duplicates, they're longer, just like names, but also emails can change and get deleted, or if they want to switch it, it could cause issues.
Exactly. People may change their emails. We want to, like, primary keys are important. We use them to link the tables. They are indexed later. So we don't want to, like, change our primary keys. We want something to be fixed, like a student number, employee number, and these kind of things. Preferably something numerical, compared to if you have some options like email and student number. Of course, the student number is a better option for the time, right? And so what else? We explain associative entities. You know all these signs right now. Data naming rules. We have to give entities, relationships, etc. the name. That is clear. And most of the time using noun for the entities, right? Because, for example, the entities are things, are places, are people. So they are often the name. Now we give them the noun. And verb for relationship, because they represent an action or a relationship, right? For example, we say a student enrolled in a course. A customer purchased product, right? So purchase is an action, right? Is a verb. Is not like customer or product with its own attributes, right? There are few like exceptional cases, right? Like composite entities, which were relationships, and they also had their own attributes, and they could become also the type of entities. But in general, when you say customer purchase product, right? Customer purchase product, then it's purchase is a verb, right? Is an action. Is purchase an entity? Yeah. Let's say, consider this one, a customer and order, okay? So, what is the type of relationship here? Is it one-to-one, one-to-many, or many-to-many? Customer and order. Anyone else? So, from next session, I start my Kahoot games with you. So you can skip. You have to answer. So that was really good way to engage all of you. And then you may come in the podium, and then you get a bonus, and you get excited, and then you engage more in the class. But yeah, it's hard to encourage without any like motivation bonuses, right? Anyone? Customer and order, what is it? Is it one-to-one, one-to-many? Please, hands up. Yes, thank you. Many-to-many. Many-to-many. So, many-to-many means customers can place many orders. Each order can be placed by many customers. So, is that true? Is partially correct? Yes?
I'm just about to ask, in terms of order, could you specify a little bit more? Like, is it a repeatable process, or is it specifically like a one unique order?
One unique order. Yeah. For example, let's say I say a customer place an order. Okay. Now, this order can include multiple products. Let's say you go into like Uber Eats and you order a pizza, another pizza, and maybe some fries, and it's your cheat day, ice cream, I don't know, you get a lot of things, okay? So many products. So your order can include multiple products. So you also have a product here, right? And this is your order. So we said each customer can place many orders, but like each order also can belong to many customers. And if not, what is the problem with that? Yes, if you want to like.
Yeah, I understand it now. So like if I place one order, it cannot go to anybody else, it will come only to me. So it's a one-to-many relationship.
One-to-many, exactly, right? So yeah, it just to maybe I wasn't clear to differentiate between order and product, right? If you consider it as a product, yes, there is a many-to-many. But the thing is, the relationship is through an order. Like customer place an order, and order includes products. Now, if we focus on the relationship between customer, only customer and order, right? This is a one-to-many relationship, right? Because each customer, okay, now you tell me. Each customer can place many orders. Each order can be placed by only one customer, right? Now, where should I put the many? Where should I put the one sign? More hands-on.
You put the many at the order side.
Many on the order, exactly. And each order can be placed by only one customer, right? And always write the names for your relationship, okay? Don't leave it like this. Customer place orders. And so this is a one-to-many. Now, it's not the scope of this session, but since I already talked about this today and we discussed it a lot, if you want to convert this later to your tables, where should you add your foreign key? So we said if two entities are connected, it means the tables later are linked, right? Have relationships. So if you have a customer table, right, with customer ID, customer name, etc., and this is your primary key, right, in the customer table, and you also have an order table with order number as the primary key, right, and maybe order date, etc. So this is customer ID, first name, last name, and maybe more attributes. And then for the order, we have order ID, date, and maybe more attributes. So I want to see at least 20 hands up, please. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Thanks for your help. 12, 13, 14. 6 more. Yes, hands up. Wake up. Okay, good. We reached to 20. Yes. Yeah.
Oh, many.
No, back of the class. You raise your hand, yeah. So we have a customer and order, okay? I'll help you. And we said each entity will become a table. So customer converted to the customer table. Order entity is an order table now, right? And the attributes will become the columns of our tables. Now we have a customer table with customer ID, name, and other attributes. We have the order table with order number, date, and so on. And because these two entities have relationships, which means customer places order, later I want to, like, as a database analyst, I want to ask you to query, for example, all the orders placed by a specific customer. Find out all the orders placed by Mona, right? Or there is a specific order or orders, I want to see who placed those orders. So there should be a link here, right? How do we connect tables?
Associative.
Connecting the tables, not the entities. How do we link the tables together? Some of you are really active. I really like that. Yes.
I think the same way we do.
Hey, yes, with the white hat.
A foreign key.
Foreign key, exactly, right? Most of the time. To a common, let's say to a common field. Now, what could be the common field here? Either order ID or order number. I don't want you to memorize. I can easily tell you, always add foreign keys. If you are like good in memorizing, always add foreign keys to the many side. What is the many side? Order. So add the foreign keys to the order table, which means adding the customer ID here, right? So this is the way if you want to memorize. Now let's say you can't memorize things. You like me, I have like a fish memory, right? So in that case, you have to find a way to reduce your struggle. So what do you do then? So you have two options: either adding the order ID to the customer table, right? Which means you're adding the foreign key to this side, right? You add the order ID to the customer. If I add this, we said each customer placed multiple orders and doesn't work, right? This doesn't work. So we end up adding the foreign key here. We have no more choice. So this is your primary key. This is your foreign key. I think I already taught you everything. Honestly, I think we have nothing more to cover. Okay, practice, yeah.
Could you explain the foreign key? Foreign key, could you explain?
Yeah, so you can think of a foreign key as a primary key that appears in another table, right? So, for instance, so basically, foreign keys, the job of foreign keys are to link the tables together, okay? And so, for instance, when we say customer place order, right, we want to show that relationship in a way in our table as well. So, for example, at the design level here, we use the relationships, right? Customer place order, and we show that, for example, the type of relationship is one-to-many or other types. Now, how do we show it in terms of our tables later, right? So, in order to understand that, I explained the concept of foreign key, that is a common field, right? That connects actually two tables together. Now, in this case, customer ID, right, is that one. Because we said we have two options. We either have to add the order ID here as a foreign key, which doesn't work because each customer placed multiple orders and we cannot store multiple values in one cell in relational tables. So we have to add customer ID here because each order is placed by one and only one customer. Each order belongs to one customer. So it doesn't create any problem here. Now order number 1, customer ID 100. Order number 2, customer ID 250, and so on. Now this is like all the rules that we applied about the relational databases applies here. So first, foreign keys link tables together to each other, right? Second, they are often the primary keys in another table. So customer ID in the order table is foreign because it was a primary key in the customer table, right? And its job here is just to link these two tables together. So this is just so that we can later join tables. Because later, when we have hands-on on SQL and you learn, for example, to join tables, let's say you write, for example, select a store, for example, from, let's say one table customer, right? I show it with C. And table order. This is one way to join them. Or you use, for example, from C, join the other table, I write table 1, table 2, which is more general. And then table 2. Now, how do you join tables? You have to specify on which field, what is the common field between them. So, for example, table 1, column 1 is equal to table 2, for example, table 1 primary key is table 2 foreign, right? Which means when you connect the customer table to the order table, you are doing it through the customer ID, and customer ID is the client. Now let's say we have an employee table with all the employee information, okay? And then you have, you also, okay, you are maybe creating a small database for just an office, not office, sorry, for a business where you have a department, employees, and I want you to specifically focus on these two for now, okay? So what do you want to store in the employee table?
Sorry, can you repeat?
Let's say we have an employee table. So, okay, good. Think yourself. And so let's say you have an employee table, and we also have a department table, okay? So what do you want to store in each table? You can think about all the employees working at York University, for example, right? So in the employee table, we want to keep track of the employees, right? Like employee number, employee name, and so on. And what about in the department? Yeah.
Probably some sort of department ID and the name of the department, maybe where it could be located if there's a specific building.
Yeah. So you have two tables, employee storing employee information, department storing department information. Now, I want to ask you to tell me, for example, find out which department Mona is working in, right? Or, for example, find all the employees working in ECS department, finding all employees working in business department, or finding the department of a specific employees, right? So to answer such questions, you need to link those two tables. So when you're designing your database, at this, even at this level, you always have to think about later what you want to do, right? What type of queries or questions you may want to answer. And those questions help you understand which tables should be linked together or which entities have relationships. So for example, what is your goal of designing a database for, let's say, an e-commerce application or website? What is the goal? Keep track of users, orders, purchase history, and so on, right? So you want to keep track of whatever user did, right? So you want to have the link between user and all his actions, such as purchases, right? Or orders. That's why we link the customer to order, because we later want to see, for example, which customers placed maybe more orders. We can do lots of analysis. Maybe you want to even see which, for example, at a specific locations, for example, which products were sold more. Maybe in some regions, some other products are sold better. What are your loyal customers and so on. So a lot of things. And so back to the employee department. Now, employee has employee information, department. I ask my question. I want to see, for example, what are the employees of a specific department and vice versa. How should we link these two tables? More hands up, please. Okay. I was always that student that my hands were up, even if I didn't know the answer. Really, my hands were always up. And just don't be afraid. It's we all make mistakes, right? Yeah.
Because it's a one-to-many relationship. Every employee has their own department, but there's a lot of employees for each department. And we should link the department to the employee table.
We should link the department to the employee table.
As in,
that means we don't have to link the employee to the department table. So I'm removing this one. So let's say I have an employee and I have department table. Or in terms of entities, I have employee and I have department, right? So here we have employee ID, which is the primary key because can uniquely identify each employee in this table. We have employee first name, last name, and so on. Here we have department ID as the primary key, and department name, maybe location, and so on. So, and we know these are connected. We said these are linked, right? So it's not like we link the department employee or employee to the department. They are both linked, right?
The foreign key of one key will be that the department ID will be in the
Okay, yeah. So let's say this is the employee table. So we have employee ID here and maybe name. So your assumptions was that each employee can work only in one department, okay? So if that's our assumption, then you are correct. So each employee can work in only one department. Each department can have multiple employees working in that department. So this is a one-to-many. Always foreign key you should add it to the many side of the relationship, which means, what is the many side? Employee side, right? Which means you have to add it to the employee side. So you add the department ID to the employee table because each employee, let's say employee Mona, can only work in one department. For example, if I'm in ECS, I cannot be in another department, right? But in ECS, right? In ECS, we can have many employees. So if you had an employee, then there were many employees there, right? That's why it doesn't work. And we add the department ID to the table as we said.
If it's a one-to-one relationship, it doesn't matter.
It doesn't matter. If it's a one-to-one, you can add it in either side because then you have no problem, right? The problem was the many part, right? The problem is, for example, when you say, for example, you have the department here, for example, ECS department, and each department can have many employees, right? And you cannot store multiple values in one cell. But as long as they are one-to-one is okay. So let's practice this together. Let's say if these are entities, attributes, or what? So a student name, everyone together, attribute, salary, attribute, employee ID, course, entity, invoice, entity, teach, relationship, search, relationship, product category, unit price, product description. So you can better realize how to define an entity, how to differentiate an entity from an attribute, right? At the beginning of the class, some of you were considering a student as, for example, attribute of the course, or I don't know, a classroom as attribute of something else. So now you can better understand. Although I have to correct myself, like a classroom, if your design is very simple, you can consider classroom as an attribute for the course entity. And why is that? Let's say you have an entity course, right? You have course ID, course name, course description, and so on. And I'm adding also the classroom here. Can you tell me in what scenario that could make sense? I mean, what scenario I can add classroom as an attribute of the course? And to help you, this is when my design is very simple and I simplify everything. Yeah.
If that classroom specifically belongs to that course, like only in that classroom we can run that course, for example. Let's say if in this classroom we can run ECS 3421 and another ECS, but in that specific classroom it's only ECS 3421.
That's one, but we can also identify that with a one-to-one relationship, right? Yeah.
The room number. Like sometimes people forget.
Yeah, correct. Yes, this is exactly what it is. So if your design is very simple, that you only want to know, for example, what is the room number or classroom number, right? And you don't care about storing classroom-specific features. So what are attributes? Attributes are characteristics of the entity that we want to keep track of, right? And the entity itself is like a thing, place, something that have like some of like these attributes, right? So in this case, for when we consider classroom as an attribute of the course, is often when, for example, we refer to classroom only as a classroom with some number. For example, we say ECS 3421 in this room, and ECS 4412 in the other room, and so on. You don't want to store classroom information, right? For example, what are the characteristics, could be potential characteristics of the classroom as an entity that you may want to store some features for. For example,
room number, capacity, and maybe if you want to categorize it into like lab versus lecture hall or something like that.
Yeah, the equipment, like if you think of it like the design at York University, so the database at York, like at least the registration, like student enrollment and registration, I probably think that they use, like I'm 100% sure, that they use classroom as an entity, right? Because we can access all the classroom features, right? Which means classroom at York University was not designed as an attribute. Because if the classroom was attribute, how come that I can access, for example, the class capacities, technologies, and everything in each class, right? So you can check, for example, if I'm going to teach a course, I don't know, a class at an ACW, blah, blah, blah. And if I didn't hear the building, I can go and check the classroom. I can see what technologies are available. So if I want to, for example, record my class, if that is possible to use the technology in the class or not. So we have access to the capacity of the class, to the technologies, and maybe it's could be, for example, for lab or not, and many other features. So in that case, that's an entity because we want to keep many information about the classroom. And ERDPlus. So for this one, we practice more next session, but I would like you to go to ERDPlus. So this is actually very helpful. This is free. So and you can you have two options. You can either either, for example, click and try it, okay, and then start working here. For example, adding an entity. Right? You just sorry. Can you see now? Okay. Now, you can have, for example, an entity, let's say a student, right? And you write a name here, right? And then you can add the attributes here. So you just click on add attributes, and then, for example, you write student here, and adding other attributes. And you can also identify the type of attribute. So we are going to talk more about the type. So far, you know, a regular entity, you know, for example, a composite entity. And we further talk about the types of attributes in the next session. But for now, you have several, can you please listen to me for a minute? So you have several models in your slides. And I want you, like before next session, I want you to practice a little bit with ERDPlus. And I also recommend you to sign up. This is free. And I've used it several times in previous classes. It's very easy and straightforward. Try to work with it. It seems easy, but you have to get used to it, okay? And then we'll practice more next session. Do you have any questions?
Would you like courses here? Examples?